Examples of a steady state process. In this section, we'll consider a number of examples of a steady state process in which there is one fluid stream entering, one fluid entering and one fluid leaving the control value. Such that the first law can be written as this equation. Q plus HI for our example in this section plus W. The first device is heat exchanger. Some any state utilize control volume that include more than one fluid stream, such that it is necessary to rewrite the first law in the more general if it is more than one flow stream. The first example, heat exchanger. Heat exchanger for the as an example of a steady state device and control volume with one flow entering and one flow leaving the control volume shown in this picture. A heat exchanger, steady state heat exchanger, is a simple fluid flow through a pipe or system of pipe. Where heat is transferred to the form to or from the fluid. Heat transfer to or from the fluid. The fluid may be heated or cooled and may or may not boil. Heated or cooled may or not boil, changing from liquid to vapor. or condense, and changing from vapor to liquid. One such an example is the condenser in R134 refrigerator system as shown in this picture. Superheated vapor enter the condenser and liquid exits of the condenser. The process such tends to occur in the constant pressure since fluid flowing in a pipe usually undergoes only a small pressure drop because of fluid friction at once. Small drop of pressure undergoes at the same or occurs at same pressure. The pressure drop may or may not be taken into account in a particular analysis. There is no means from doing any work, so W equals to 0, no work, and change in kinetic and potential energy are commonly negligibly small, and change in kinetic energy and potential energy is negligible for a heat exchanger. One exception may be a boiler tube in which liquid enters and vapor exits at a much larger specific volume. In such a case, it may be necessary to check the exit velocity also. The heat transfer in most heat exchanger is then found equation as the change in enthalpy of the fluid. So with this description, we have Q plus HI, the potential and kinetic and potential energy, HE plus kinetic, in fact the difference of, let me write at the delta V Q square and delta GZ equals to HE plus W. In this case we have the change in kinetic and potential energy equals to 0, so also W equals to 0, Q equals to HE minus HI, or Q dot M dot HE minus HI for a heat exchange. Steady state heat, steady state. As shown in this picture, we have the heat transfer out of the condenser, then goes to the whatever is receiving it, perhaps a stream of air of cooling water. It is often simpler to write the first law around the entire heat exchanger, including both flow streams, in which cases there is a little or no heat transfer with the surrounding. Such a situation is the subject of the example in the example 3 in the example parts. The next device is nozzle in the next video part.